Alright, welcome back again. So we are picking up from looking at the structure of benzene to naming benzene compounds. Alright, so these are the more popular compounds that you will come across. Okay, especially this one, this. Right now, depending depending on the group that is attached to the benzene ring, the name of the benzene, it might vary. So for instance, if you have a NH2, benzene does not appear in the name at all. So with the NH2, it is called phenyl. So this is a phenylamine. So benzene with an amine group is called phenylamine, and its common name is aniline. This one, benzene, is retained. So it's a methyl benzene. When you say OH group, we just call it phenol. Alright? So you just need to remember these different specific ones. When you have the carboxylic group, we just call it benzoic acid. Or if you want to say benzene carboxylic acid, but it's most commonly called benzoic acid. Alright? And this one, the NO2 group, that's the nitro group. So we say nitrobenzene. This one is a ketone. Again, here the name changes to phenyl. So it's the ketone portion is 2 carbons. So we say phenyl ethanol. Alright? And this one's an aldehyde, so we say benzaldehyde. So with these two, sometimes the benzene and the other functional group, the name combine as one. As you see, benzoic and benzaldehyde. Alright? So these are the ones with specific functional groups attached. Right? So we will look at some more now with bromo and chloro, those sort of functional groups. But ensure you remember methyl benzene, phenyl amine, phenol, and nitrobenzene. Alright, so here we have some more compounds. Alright, so the first one, we know that Cl is a chloro group, so we just say chlorobenzene. You don't need to say one chlorobenzene, because once you have one group present, then automatically it has the number 1 position. Alright, for this one, alright, we have chloro groups, 2 of them, so it's dichlorobenzene. And as you can see, they are, if you count in this direction, it's 1, 2, 3. So it is 1, 3 dichlorobenzene. And for this one, we know that nitrobenzene, so the nitro group would form the parent name. So you have nitrobenzene, right? So the substituent is bromo, and that would be on carbons 1, 2, 3, 4. So it's 4 bromo nitrobenzene. And of course, a benzene ring with OH, that would be phenol. And we have the chloro group present, so that is chlorophenol. And there on carbon, we have 3 of them, so it is trichlorophenol. There on carbons 2, 4, and 6. So it is 2, 4, 6 trichlorophenol. Alright? So those are some other compounds. The last one I will do is an ester. Alright, so this is the benzene ring, and this portion is the carboxylic acid. So in this instance, the benzene ring, I'm going to call it phenyl, and we know that when the carboxylic acid portion, it's two carbons, right? So we know that that is going to be called ethanoate. Ethanoate. So it is phenyl ethanoate. Alright, so those are just some compounds for benzene that we will name. Now the next thing we're going to look at about the benzene ring is each carbon on the benzene ring is given a particular name. So carbon number 1 and 4, carbon number 1 and 4, those are termed para. So positions 1 and 4, we call them para. Position number 2, so with benzene, you can count clockwise or anti-clockwise. So both of these positions are position number 2. Alright? So position number 2, we call it ortho. Alright? And position number 3, it's called meta. So if we're counting in this direction, then this is number 2. If you count this direction, this is number 2. So both of these are number 2, and that's also number 4 is para. And number 3, that's meta. Number 1 won't really be using number, even though we say para is 1, 4, para is basically number 4. And the reason for that is because these groups becomes important, or the position becomes important when you have a group on the ring. Alright, so for instance, you have the OH group. So number 2, that's ortho. Number 4, para. 3 is meta. Alright, so what are the importance of these positions and the group? When a particular group is already on the benzene ring, any other incoming group will be directed to either the ortho, meta, or para positions. Alright? So the reason why we are giving you these positions now, when you have a particular group on the ring, if you are trying to add something else, it cannot go anywhere on the ring. It is going to go to a specific position. So when you have an empty benzene ring, right, and you're adding something, then it can go anywhere. But once you already have something on the ring, it is going to direct it to a particular group. So for example, we have phenol and we have nitrobenzene, right? We have two types of groups now. So when you have groups on the benzene ring, we classify them into two categories, alright? So let me just erase this. So we have groups now that we call activators, right? So we have the activating groups and we have the deactivating groups. So we have activating and deactivating groups. Now the activating groups, they tend to pull electrons from the ring. So the activating groups pull electrons from the ring. And when they pull electrons from the ring, that makes the ring less, sorry, this is not activator, this is deactivator. So the activators release electrons to the ring. And so they make the ring more reactive. So the ring will become ring becomes more reactive. Alright, and the final thing about the activators, they are ortho, para, directors. Alright, so the OH group is an example of an activator. It is an activating group, so it tends to release electrons to the benzene ring. That makes the ring more reactive. When you say more reactive, it will tend to attract an electrophile towards itself more readily, alright? Because the electron density around it would have been increased. And anything you're adding to phenol or a next activating group present, it will direct it to the ortho and the para positions. Now the deactivating group is the opposite. So instead of releasing electrons to the ring, it pulls electron from the ring. If it is pulling electrons from the ring, that means the electron density on the ring is decreased, and so the ring becomes less reactive. Alright, and finally, they are meta directors. Alright, so if you have phenol and nitrobenzene, alright, and we have an electrophile. So you have phenol and you have nitrobenzene, and we have an electrophile. The electrophile can go here, right? Or it could go here. But for the nitrobenzene, it will go to the meta position. So if you have phenol present, most of the products will have the electrophile in the ortho and the para positions. But if it's nitrobenzene, most of it, about 90% or more, you will get the electrophile in the meta position. That's because the nitro group is a deactivating group. The OH group, that's an electron releasing group. It is an activator because it makes the ring more reactive. So the most common activating groups would be, let me erase this, any alkyl group. So we know the OH group, right? Any group with the NH2 and any alkyl group, alright? Anything with amine, any alkyl group, alright? those are releasing groups. That means methyl benzene, the methyl group, is also an auto para director. So phenylamine, methyl benzene, and phenol, those would be auto para directors. If you're adding anything, it would go auto and para. And for this one, for cape, you're most likely going to get nitrobenzene, and the other deactivators are the halogens. Alright? You have more activators than deactivators, but for cape, the halogens and the NO2 group, those are the ones you're most likely to get. Alright, and for the activators, it's the OH group, NH2 group, and the alkyl group. And if you want to see more, you can always Google them. But these are the most likely ones that you will come across. The OH group, NH2, and the alkyl group. Those are activators. The NO2 group and the halogens, those are your deactivators. Alright, so we have looked at naming benzene. Now we know about the auto and para positions, and you know about the activators and the deactivators. That means we can move on now to the reactions of benzene. Alright, I think I'm going to end this one here as well. So that's it for this video. I'm just going to do part 3 with the reactions of benzene. Alright, so I will stop here for this one.